Hello everyone, today I'm about to do quadratic sequences. Quadratic sequence. Okay, a quadratic sequence is a type of a sequence that has two differences together. The general term for quadratic sequence is given by this formula. Together. There are two things that are mainly important for a quadratic sequence. The first one is that number one is that the first difference is arithmetic or linear. Together, and therefore the second thing is that the second is common. Together. So if you have a sequence and if you have a sequence, these two things need to stand together. So if ever you have a sequence like this, you have A, B, and C like this together. For you to find the difference, let's say you'll get D and then E here, and then since the second difference is X, it will be X one way. Together. Okay, for you to find the general term that will generate all the terms of a quadratic sequence, you need this thing. You need the value of A, B, and C. How can you find A? It's just simple. You go to your second difference and be like 2A is equal to the second difference, and then for you to find B, you'll go like 3A plus B is equal to the first term of the first difference, and then for you to find the value of C, you'll be like A plus B plus C is equal to the first term of the sequence. How so? Let's say we have a question like this. Let's open this. Yeah. Let's say we are given this type of a sequence. This one. We have 4, 5, 8, and 13 are together. And we just need to answer these questions. We must find the next three terms, determine the nth term, and then answer these two questions. Okay, firstly, we know that our sequence is 4, 5, 8, and 13. For us to find the next term, we need to know the value of the first difference as well as the second difference together. So our second difference is 2, and this thing is common. So 5 plus 2, we get what? We get 7. 13 plus 7, we get 20 together. Then the next one is 2. 7 plus 2 is 9. The next term is 29. Here the next term will be 40. So this is how you find the terms of the following terms of a quadratic sequence. You just need to take the previous term. I took 13, I added the first difference. I got 20. Then 20 plus the first difference, which is 9, got 29. 29 plus the first difference is 40. Right, together. So this is how you get the first 3 terms of the sequence. Now let's determine the nth term. We know that, let me write this in red. 2a is equal to the second difference. 3a plus b is equal to the first term of the first difference, and then a plus b plus c is equal to the first term of the quadratic sequence. Okay, firstly we need to find a now. So how can we do that? We'll be like, okay, 2a is equal to 2. I can divide both sides by 2. That means a is equal to 1. Right, together. Then now I need to find b, because the only things that I need to find the general term is a, b, and c. Okay, and therefore I'll be like 3a plus b is equal to 1. 3 multiplied by 1 plus b is 1. Therefore b will be equal to 1 minus 3, which is negative 2. Are we together? Now I know the value of a and b. I'm only left with I must only find c now. I know that a plus b plus c should be equal to the value of the first term of the sequence, which is 4. A, I found 1, b, I found a negative 2, and then c is equal to 4. I have negative 1 plus c is equal to 4. Therefore c is 4 plus 1, which is equal to 5. Are we together? Therefore now I do know my Tn. Since my Tn is given by an squared plus bn and c, I can simply substitute these numerical terms. Tn is equal to, whenever I see a, I must put 1. I don't need to write 1. Whenever I see b, I must put a negative 2, like this. Whenever I see c, I must put a 5 there. So this is my nth term. This equation is the one that generates all the terms of this specific quadratic number pattern. Are you together? The same thing applies, guys. Whenever they want you to find the position of a term, they must give you the term itself, and then you must solve for n. Are you together? In this case, we are asked which term of the sequence is equal to 229. Okay, it simply means I'll be like, okay, Tn, which is equal to n squared minus 2n plus 5. Whenever I see Tn, I'll put 229 here like this, and then I'll have n squared minus 2n plus 5. I'm solving for n. I want to know in which position is 229 at. So I'm solving, and this thing is a quadratic equation. Are you together? If you're still struggling with solving quadratic equations, don't be shy. Go back to the first 2 videos whereby I teach you how to factorize from scratch and how to solve x, or how to solve quadratic equations. Okay, in this case I just need to put everything in standard form. Plus 5 minus 229 is equal to 0. Therefore n squared minus 2n minus 224 is equal to 0. Are you together? So now I just need to factorize this thing. I need the factors of 224. That's when I subtract would give me 2. The factors of 224, that's when I subtract would give me 2. Those are 16 and 14. Are you together? The bigger factor will always take the sign of the middle term. We have n here. Okay, that means n is equal to 16, or n is equal to negative 14. This one is not applicable because n, whenever you deal with sequence, n is the number of terms. You cannot have a negative number of things. Are we together? So therefore T16 is the one which is equal to 2229. Are we together, guys? And then the fourth question, we are supposed to calculate n if the last term of the sequence is equal to 404. Okay. They've given us the last term of the sequence, which is 404. I know that Tn, which is equal to n squared minus 2n plus 5. Since I'm given the last term, I'll just substitute it here. 404, and then solve for n. N squared minus 2n plus 5. N squared minus 2n plus 5 minus 404 is equal to 0. So I'll have n squared minus 2n minus 339 is equal to 0. I want the factors of 339. 339, not 339, man. 399. That's when I subtract will give me 2. And those factors are 21 and 19. The bigger factor will always take the sum of the middle term. The sum of the middle term is negative, and then we'll go here. Then n is 21, or n is negative 19. This one is not applicable. So therefore, the conclusion should be there are 21 terms in this sequence. Are you together? So this is how you deal with a quadratic equation type of question. Let's do one of these. Let's go for number 16. Okay, number 16. Now the sequence is not given to us. I believe it's easy whenever a sequence is given to us. Like, I think we must deal more with situations whereby a sequence is being described to us. Right, together. Okay, here we have a situation whereby a quadratic sequence has the following properties. The second difference is 5. The first two terms are equal, such that T1 and T2 they add up to not they add up, man. T1 is equal to T2, and then the third point we are told that T1 plus T2 plus T3 is equal to 28. Okay. You must show that the general term of the sequence is that if you can say that let T1 be equal to x, it will be simple. We know that the first term is x and the second term is x, since we're told that they are equal, right? Since the first two terms are the same, that means there's no difference between them. Are you together? But I'm also told that the second difference is 10. And the second difference, I know that it's constant. It will always be 10. Are you together? So if here I have 10, for me to find the second term of the first difference, I'll say 0 plus 10. I'll get another 10. Let me write it in blue. 0 plus 10, I'll get another 10. Are you together? And then for me to find the third term of the quadratic sequence itself, I need to say x plus 10. I'll get x plus 10. I know here I have 20 because I have x plus 10, it will give me 20. And the fourth term will be what? X plus 10 plus 20. That will be x plus 30. Okay, basically for us to find the nth term, we must be able to find the value of x so that you can find the equation. Are you together? We were told that on the statement here, we're told that the sum of the first three terms is 28. In our case, you know that okay, since t1, t2 plus t3 is 28, and initially we said t1 is equal to x. That means this one is x as well, plus t3, this thing is equal to 28. So it simply means that t3 is 28 minus 2x. Are you together? According to what they gave us, but according to our own findings, we found out t3 is equal to x plus 10. So these two terms, they represent t3, so we can make them to be equal. We can say that's 28 minus 2x is equal to x plus 10, because whenever we try to analyze what we are given, we found out our third term is equal to this. So these two things are equal, right? The only thing we need to do is to just solve for x. We have an equation now. Are you together? And whenever I bring x to the other side, what will I have? I will have a negative 3x, né? And then when I take 28 to the other side, I'll have a negative 18. So x will be equal to 6, because I'll divide both sides with a negative 3. Are we together? So I now know that that means the first term is 6 and the second term is 6. The third term, since it was x plus 10, the third term should be what? Should be 16. Now let's find the other information. Here we have a 0, and then here we have a 10. That means the second difference will be 10, 10, 20, 26. Let's check whether did we have this and this there initially. Yes, we did, and then the rest will be the same. So now it's easy. I know the numerical value of the first term, the numerical value of the first term of the first difference, and the numerical value of the second difference. So I can simply say that 2a is equal to this, 3a plus b is equal to this, a plus b plus c is equal to this. So this thing simply means that 2a is 10, then a will be equal to 5, and indeed a is 5. Now let's go and find b. I know that 3a I know that 3a plus b should be equal to the first term of the first difference rather. This is 3 times 15 plus b is 0. That means b is negative 15. Are you together? I know that a plus b plus c should be equal to the first term, which is 6. A is equal to 5, b is negative 15, and then c, excuse me, I have negative 10 plus c is equal to 6. That means the value of c is 16, as it is supposed to be. So therefore Tn is equal to Tn, which is equal to an squared plus bn plus c. I know that the value of a is 5. I'll just put a 5 there. The value of b is negative 15, and then the value of c is 16. Now I have shown that Tn is equal to that. The following question is simple. I'm asked that is 216 a term in the sequence? Tn I do know the value of Tn. The equation of Tn was 5n squared minus 15 plus 16. I'm asked that this term is a term in the sequence. Okay, there are two ways I would have gone with this. Firstly, I was going to solve for n. If I do find a solution, that means this term is part of the sequence altogether. Secondly, I would have gone with the nature of roots. Find delta, and then if delta is greater or equal to 0, that means this term is in the sequence altogether. So let's first do it by solving. We'll have 5n squared minus 15n minus plus 16 minus 216 is equal to 0. 5n squared minus 15n minus 200 is 0. Then I can divide everything by 5. I'll have n squared minus 3n minus I think that's 40. Yes, it is 40 equal to 0. I want the factors of 40. That's when I subtract will give me 3. Those factors are 8 and 5, minus and plus. That means n is 8 or n is negative 5. This one is not applicable. You can't have a negative number of terms. It simply means that the 8th term of this sequence will be 216. Are we together, guys? The other way, if you didn't want to be direct with it, that find the position where this term is in, you can just use the nature of roots. I know that 216, which is equal to n squared minus 15 plus 16, is equal to n squared minus 15 minus 200, which is 5 there, is equal to 0. N squared minus 3n minus 40 is equal to 0. Then if I can find delta, and I find that delta is greater or equal to 0, I can therefore conclude that this term is part of the sequence. B is negative 3 squared minus 4 AC. This thing is 9. This one is 160. Yes, and then we have 169. 169 is the same as 13 squared. 13 squared. 13 squared. So delta is a number which is greater than 0, and delta is a perfect square. That means n is a rational number, and of it is true because n is n give us the number of things, so we cannot have number of things which are decimal. So we could have done it this way, or just solve for n. It's up to you how you want to do it. Let's do the second one. The second one, we are given a quadratic sequence. We are told that a quadratic sequence is defined with the following properties. We don't know the first term, right? But we know that when you say, for you to find the first term of the first difference, you must say t2 minus t1, and that will give you 7. This will be x plus 7, and then we know that here we have 13 because we are told that t3 minus t2 is 13. That means here we have x plus 20, and then here we have 19. That means here we have x plus 39. Okay, and then we are asked to find the thingy. Number 1, t4 minus t5. It's just the fourth term of the quadratic sequence. No, it's the fourth term of the first difference rather. Are we together? Okay, I can see the trend here. The second difference is 6. So 9 plus 6 will be equal to 19 plus 6 rather is equal to what? 25. So that's my answer there. Now secondly, they want me to find t70 minus t69. Okay, t70 minus t69 is the same as the 69th term of the first difference, so I'm going to call it 69. All right, together. And how can we do that? The first difference, guys, is arithmetic. All right, together. The first difference is arithmetic, so therefore we can conclude that Tn, let me call it Dn because dealing with the difference, ne? Dn is equal to a n minus 1 d, ne? The value of the first term of the first difference is 7. Let me write in black. It's 7, ne? We want to find term number 69. So whenever we see n, we'll just put 69. The difference is 6. So term number 69 of the first difference will be equal to 7 plus 69 minus 1 times 6 will be equal to 415. Are we together, guys? And then B, they want us to find the value of the 69th term of the quadratic sequence if the 89th term is equal to that. Okay, we know that we don't have the terms of the quadratic sequence. Are we together? We only know the second and the first difference. Here we were told that 7, 13, here it's 19, here we have a 6, 6, 6, we calculated the 25 there. All together. But we know that 2a is equal to 6 because always the time, guys, remember this, 2a is equal to the second difference, 3a plus b, the first term of the first difference, then a plus b plus c should be equal to this. All right, together. So here it simply means that a is equal to 3. I know that 3a plus b is equal to 7. Simply means that that means b is equal to what? A negative 2, because we'll have a 7 minus 9. we don't have to find the value of a because we don't know that term there, no? So I have Tn is equal to, not the value of a, rather we cannot find the value of c because we don't know the value of the first term. Tn, which is equal to an squared plus bn plus c, is equal to what? Is equal to 3n squared minus 2n plus c. This thing is Tn, but I know that whenever my n, this thing was given to me, that whenever n is equal to 89, I will have 23,594 right together. So I will have 23,594 if and only if my value of n is 89. So by just doing this, I can find the value of c. I will have 89 here, 89. 3 multiplied by 89 squared minus 2 by 89. This is 23594 is equal to 23585 plus c. Therefore c is equal to 23594 minus 23585. What do we get? 23594, we get 9. It simply means that our sequence is given by 3n squared minus 2n plus 9. Therefore I can find the 69th term. I can simply say T69 is equal to 3 multiplied by 69 squared, 69 plus 9, and then this thing will be equal to T69 will be equal to 14,154. This is how you tackle questions whenever a quadratic sequence is described to you. You must first find the nth term and then answer everything they want you to find. I hope this was helpful, guys. Please stay tuned, subscribe, follow, watch videos, comment, criticize if you have to. I believe in constructive criticism because it can help me to grow. Stay tuned, guys, and thanks for watching the video. Bye.